Good afternoon to students and everyone who are viewing my lecture video. Myself Sushri Priyadarshini, lecturer in mechanical engineering at Bose, Cuttack. So, it is my second class of air compressor. In the first class of air compressor, I had already told you about some contents of air compressor, that is from the thermal engineering 2 of 4th semester mechanical engineering. So, in the second class we will discuss the further details about the air compressor. So, today we will discuss about the terminologies. Terminologies of air compressor. What are the different terms which will be used in air compressor? So, first one is single acting air compressor. Single acting air compressor. I am elaborating about this single acting air compressor. That means, in this type of air compressor, the suction, compression and delivery of compressed air, compression process happens at one side of the piston. That means, suppose this is the cylinder and inside the cylinder the piston is there. If the suction, delivery and the compression process, this is the compression process when the piston is moving, this is the compression process and this is the inlet, this is the suction process. That means, through the inlet the suction of air will occur and through the outlet delivery of compressed air will occur. Delivery of air. Delivery of air. Okay. If all these three processes will happen at one side of the piston, then that is called as single acting air compressor. Clear? Then coming to the double acting. Second type is double acting. In the double acting air compressor, what will happen? The suction, delivery and compression process will happen at the both side of the piston. That means, the diagram will be like this. Suppose this is the piston cylinder and this is the piston, and here another inlet is there and delivery is there. Inlet and delivery. If this suction of air and delivery of air and compression also happens at both side of the piston, that means, when the piston is moving upward, the suction process and compression process and delivery process is happening at this side, and when the piston is moving downward, again the compression process is happening at the downside of the piston. That means, at both sides, in one revolutions at both sides of the piston, suction and delivery and compression process are happening. That is why it is called as double acting air compressor. And why we are studying about this single acting and double acting? This is needed when we will calculate the volume flow rate of the air compressor. That term I will tell you later. But this is needed. You have to remember, this is the for single acting at one side of the piston, but in double acting at both side of the piston in a single revolution. In a single revolution, if everything happens at one side, then that is called as single acting. If in a single revolution, if everything happens in both sides, then that is called as double acting air compressor. Okay. Then coming to third term. Clear? Coming to the third term, that is single stage air compressor. Single stage air compressor. single stage air compressor. And what do you mean by staging? This is most important. What do you mean by stage, and what is single stage, and what is the difference between the single and multi-stage? Okay. So, single stage air compressor, that means all the compression process is happening in a single cylinder. Suppose this is the cylinder and air is entering, and this here air is leaving, and this is the piston. Okay, and here the atmospheric air, suppose P1 pressure, this is P2, atmospheric pressure, atmospheric air at a particular pressure is entering into the cylinder. This is the cylinder, and after the compression process, this is leaving the cylinder at particular pressure, that is P2. Okay, and these all things are happening at a single stage, in a particular stage. That's why it is called as single stage. And where this staging will come, why this stage is needed, why we are studying about single and multi-stage. Okay, single stage is needed when we do not require a very high pressurized compressed air. Okay, if the pressure ratio is low as far as, or medium pressure ratio is needed, then we can use this single stage air compressor. In one stage we can compress the air up to the desired pressure. Okay, we do not need further cylinder, we do not need further staging. That is why it is called as single stage air compressor. That means when anybody will ask you about what is single stage and why we will study about the single stage and multi staging, why we will study about the staging of reciprocating air compressor, then you can answer him like this. When the it is coming to the pressure ratio, when the reciprocating compressor is handling very high pressure, at that time we cannot compress the air in a particular stage, we need multi stages. Okay, that means in the first stage we will compress the air up to certain pressure, then the exit air will be entered into the second cylinder. Like this we will compress the air in a multi-staging process. Okay, that means when we will require very high pressurized compressed air, but when we do not require a very highly compressed air, then we can just compress the air by using this single cylinder, by utilizing only one cylinder in a single stage. We can convert, or we can compress the air from a particular pressure to our desired pressure. Okay, that means for a low pressure ratio we can use this single stage air compressor. This is very important. Okay, so coming to multi staging, all these things are needed whenever we will find out or calculate the work done. Clear? So you all should know. Coming to the fourth term, that is multi-stage air compressor. Multi-stage air compressor. So multi-stage, in I told you single cylinder we are using the one cylinder. So multi-stage thing is like this. Suppose this is the first cylinder, this is the inlet and this is the exit, and cylinder head, this is the cylinder head, and inside the cylinder there is piston, and after that another cylinder is there. Okay, and suppose this air is entering at a pressure P1 and this is P2. Clear? And this P2 pressure is entering into the second cylinder. This is the first cylinder. Clear? This is the first cylinder and this is the second cylinder. Also in the second cylinder another piston is there. Okay. So here the outlet. Suppose this is the inlet for the cylinder 1, that is air is entering at a particular pressure or at the atmospheric pressure into the first cylinder, and as per the requirement or as per the pressure ratio maintained into this in the cylinder, this first cylinder will compress the air up to this pressure, up to this certain pressure, that is at P2. Okay. And after that P2 pressurized, the pressure at P2 will enter into this second cylinder. Okay. And again the piston will compress the air in the second cylinder up to our desired pressure, that is called as P3. P3 is the final pressure or desired pressure. Okay. That means here our inlet pressure is P1, that is atmospheric pressure, and the final pressure is P3, that is our desired pressure. But we are not converting this P1 to P3 in one stage. Okay, we are not converting it. We are doing it by stage. Here I am telling you about two stage air compressor. In two stage means we are utilizing two cylinders. This is the first cylinder, this is the second cylinder. That means in the first cylinder we are maintaining a particular pressure ratio. Up to certain pressure we are compressing it, and after the compression this P2 pressured air, the air at P2 pressure will enter into the cylinder, and again that will be compressed into P3, that is our final pressure. This is the concept of multi-staging air compressor, but I will definitely tell you about this P2. What is P2? P2 is called as intermediate pressure. Intermediate pressure. Okay, that means that pressure is in between the inlet pressure and the final pressure. Suppose inlet pressure is 1 and the final pressure is 20, and this P2 is the intermediate in between the 1 and the 20 bar pressure. Okay, and this intermediate pressure, what happens actually when the compression process occurs, pressure increases as well as another term increases, that is called as temperature. What increases? Temperature. When the temperature of air increases along with pressure, that should be cooled before entering into the second cylinder, because high temperature, the air at high temperature is actually not desirable in case of air compressor, because that will generate heat, and high temperature is not our concern. We do not require high temperature air, only we require the highly pressurized air. But according to law, when the pressure is increasing, definitely the temperature will increase, the temperature of air will increase. But we need to reduce that temperature by certain means or by utilizing a particular device, that is called as intercooler. What is that? Intercooler. I am mentioning it, please view it carefully. This is a particular device is mentioned or connected in between the first and second cylinder, that is called as intercooler. Here the intercooler will be placed. Okay. And what is the function of that intercooler? The intercooler will reduce the temperature of this air which is coming out of the first cylinder up to certain temperature. Suppose this P1 and air is entering at T1 and P1. Clear? When the pressure is increasing up to P2, that means up to intermediate pressure, also temperature is increasing up to certain temperature. Clear? That means suppose T2. Suppose temperature increasing up to T2. Clear? Then the air at T2 temperature and P2 pressure will enter into the second cylinder. Clear? The air at P2 pressure and T2 temperature will enter into the second cylinder. P2 is okay, but we do not need this T2. because it is already high temperature. When again air will enter into the second cylinder, again it will be compressed, again temperature will increase. So, when the air will exit the cylinder, the temperature will be very high. So, that is not our concern. That is why this temperature should be reduced up to certain temperature. That means, we can reduce this T2 up to this T1, clear? T1, that is the entering temperature, clear? So, if by using this intercooler we can reduce the temperature up to this T1 completely, okay, completely reduce that temperature, then it is called as perfect intercooling. What is this called? Perfect intercooling. That means, if the temperature T2 is reduced up to T1 completely, exactly, then that is called as perfect intercooling. And if the T2 cannot be reduced up to T1 exactly, suppose T1 is at 30 degrees centigrade, T2 is at 120 degrees centigrade. If after the intercooling 120 is reduced up to 35, not exactly 30, 35, then that is not called as perfect intercooling, that is called as imperfect intercooling. That means, we cannot reduce the temperature of compressed air up to the initial temperature completely. That is why it is called as imperfect intercooling. If perfectly happens, then called as perfect intercooling. That is two types, perfect and imperfect intercooling. But function of the intercooler is to reduce the temperature of compressed air at constant pressure. Keep it in your mind, constant pressure. That means, pressure is what? Pressure is intermediate pressure, that is P2. At that particular P2, pressure P2, the temperature is reduced up to initial temperature, okay, or any temperature accordingly, it depends upon the intercooling process, okay. And when the temperature is reduced, suppose T2 dash, temperature is reduced up to T2 dash, and air, after that air which is at pressure P2 and temperature T2 dash will enter into the second cylinder. Is it clear? This air at pressure P2 and temperature T2 dash will enter into the second cylinder, and after that again in the second cylinder compression process will happen, okay. The compression process will happen, and in the second cylinder, after the compression process, again pressure is increasing. Pressure will increase up to which pressure? Final pressure. Up to which pressure? Final pressure. And the and temperature will be what? T3. Pressure is P3 and temperature is T3. And T3 is not much more, because we have reduced its temperature in this intercooler. Okay, that is okay for us. So, the air is at T3 and P3 will enter into, will go to the storage tank for the further utilization purpose. Clear? So, coming to some another term, that is pressure ratio. Okay. Here I will tell you pressure ratio. In the first class also I had mentioned about pressure ratio, but here it is needed because we are studying about the multi-staging, clear. So, pressure ratio is what? This is symbolized as RP, pressure ratio, that is the final pressure to the initial pressure. That means, it is the ratio between the pressure after compression and the pressure before compression. That means, here we are using two cylinders. It is the first pressure P1. How many types of pressures are there in the multi-staging? In the two stage air compressor, two types. One is P1, one is P2, another is P3. And what is P1? P1 is the initial pressure. P2, what is P2? P2 is the intermediate pressure, and what is P3? P3 is the final pressure. I think all should be clear about it. P1 is the initial pressure, that is atmospheric pressure, that is taken into the cylinder. P2 is the intermediate in the after the first cylinder compression, and P3 is the final, that is our desired pressure. We require that pressure. Okay. So, how many pressure ratios will be here? Though it is, there are 3 types of pressure, 3 number of pressures, that is why there will be 2 pressure ratios. How? One is P2 by P1 and another is P3 by P2. One is P2 by P1 and another is P3 by P2. One is P2 by P1 means that is for the first cylinder. For the first cylinder, the exit pressure is P2 and the inlet pressure is P1 and the pressure ratio is P2 divided by P1. Clear? That means for the first cylinder we have maintained, suppose pressure ratio 10, that means P2 divided by P1 is 10. Clear? Then another pressure ratio is P3 divided by P2. So, P3 is what? P3 is the final pressure, that is exit after the second cylinder, and P2 is the intermediate. Again P2 is the intermediate. So, final pressure after the compression and initial pressure for the second cylinder, that is P2, that ratio is called as P3 by P2. That means there are two types of pressure ratios, one is P2 by P1 and P3 by P2, and overall pressure ratio, what will be the overall pressure ratio? That is P3 divided by P1. Overall pressure ratio means what is our required pressure divided by what is the initial atmospheric pressure, and P3 by P1 is equal to P3 divided by P2 into P2 divided by P1. Okay. That means that is the multiplication of sir both to कटक रे सर सर मु आज तो बहुत दूर रू आसी गाँ स्टेज एयर कंप्रेसर. ओके. Then coming to fifth terminology. First one was single acting, second one double acting, then third one is single stage, and fourth one is multi stage, and fifth one is pressure ratio. Then sixth one is free air. What is free air? Free air is the normal air, atmospheric air, which is available in the atmosphere at particular atmospheric condition. Okay. That means at atmospheric pressure and temperature, the air the air is available, that is called as free air. Nothing much to tell about this free air. Then coming to seventh term, that is compressor displacement volume. Compression displacement volume. Compressor displacement volume, that is V is equal to, formula is pi by 4 d square into L, and what are these parameters? What is D and what is L? I will definitely tell you. I am drawing one diagram. This is the cylinder, and inside the cylinder the piston is there, and the piston is having some the cylinder is having some stroke length, that is TDC, and bottom dead center BDC, and this distance is called as stroke length. Okay. The piston will move from this BDC up to this TDC, and that distance from the TDC to BDC is called as stroke length, and D is the diameter of the cylinder. Clear? D is the diameter or bore of the cylinder. L is the stroke length, that is the distance between the TDC and BDC. This is the volume, compressor displacement volume. This is most important. This is also called as stroke volume. This is also called as swept volume. Clear? Most important, you have to remember this formula. Whenever the question will be given like this, the diameter is this much and stroke length is this much, find out what is the volume, compressor displacement volume, you can put this formula pi by 4 d square L and you can get the answer. Okay. So, next term is volume flow rate. Volume flow rate. And what is volume flow rate? Volume flow rate means that is B dot. And what is the formula for this volume flow rate? That is particular volume into number of revolutions into number of inductions. Okay. And how can you find out this volume flow rate? Volume, I have told you the formula pi by 4 d square L. Okay. Pi by 4 d square is the area into L, stroke length, length will be multiplied, you can find out the volume, that is pi by 4 d square into L, into number of revolutions means how many revolutions of the piston is there, sorry, how many revolutions is there, that suppose that is n revolutions. Okay. So, n for n revolution you can divide it by 60 because revolutions per minute. Okay. So, n by 60 into number of inductions. What do we understand by number of inductions? Initially, in the first terminology I told you single acting and double acting. For the single acting, the number of inductions in one revolution is 1. Clear? I told you for the single acting is what? Single acting means suction, delivery and compression process are happening at one side of the piston. That means in one revolutions there is one inductions of air into the cylinder. Clear? But in double acting, in one revolution there is 2 inductions. That means in double acting, what happens in double acting? This is the induction, suppose this is the piston and this is another inlet. Clear? That means in one revolutions, okay, in one revolution there are 2 inlets, 2 inductions into the cylinder. Clear? That is why number of inductions will be 2. This is most important when you are calculating the volume flow rate of air compressor, whether it is single acting or double acting. It depends upon the question, you have to read it carefully, you have to consider the volume flow rate according to the number of inductions, otherwise the answer will be wrong. Okay. So, for single acting, the volume flow rate B dot is equal to pi by 4 d square L into n by 60 into 1. Okay. This is for single acting air compressor. Clear? So, for double acting, what will happen? You have to just multiply it by 2. For double acting, so B dot will be pi by 4 d square L into n by 60 into 2, because I told you in double acting the inductions will happen in one revolution for 2 times. That is why the 2 will be multiplied with the pi by 4 d square L into n by 60 to find out the final volume flow rate for double acting air compression. Clear? The next term is, I am telling you about the next term. Eighth term, piston speed. Okay. So, piston speed, you can find out the piston speed, that is volume of velocity of piston, that is 2Ln. N is the revolution, RPM, revolutions per minute, okay, and you have to multiply it with the 2L. 2L, what is 2L? Why 2L is multiplied? Because the in complete revolutions piston is reciprocating inside the cylinder, and that is covering the stroke length 2 times, that is the TDC and BDC. In one revolution the piston is covering the stroke length 2 times, one is moving upward and again downward, that is why it is 2L will be multiplied with the revolutions, okay, and 2 unit of stroke length is meter and per minute, meter per minute, RPM per minute, that is velocity of piston. Okay, this is the piston speed. Then coming to next terminology, that is free air delivery. FAD, this is important. Free air delivery. What do you understand by this free air delivery? That means the after the compression process, the air corresponding to ambient condition, the air corresponding to ambient condition after the compression process, that is called as FAD. What do you understand by this, and how you can find out this free air delivery volume? That means when we are compressing all the airs in the cylinder and we are storing in a storage tank, and after that when we will allow it to expand and we will again storing that expanded volume in a particular tank, that means we are allowing it to expand up to the atmospheric condition, that is corresponding to ambient pressure and temperature, that will definitely expand. When we will allow it, that will definitely expand and the pressure will be reduced up to the atmospheric condition, and when that particular volume will be stored in a cylinder, that volume is called as free air delivered. Clear? Free air delivered. That means after the compression process, the air which is air corresponding to atmospheric condition or ambient condition is called as free air delivered, and it is required, we will find out this value free air delivery volume in your problems. Okay. Later on we will discuss. This is all about your terminologies of air compressor. Okay, this is all about your terminologies of air compressor. That means all these terms you have to understand, you have to remember, or you have to apply in further classes, and it is very needed, very much needed in the derivation of work done of air compressor, and we will utilize it while solving your air compressor problems. So, this is all about your class. In the next class we will continue with construction of air compressor and the working principle of reciprocating air compressor, and also derivation of work done. Thank you to all.